Okay, let's use the activity series and determine if these reactions will actually take place. So here's our activity series over here, with lithium being the most active of the metals and with gold being the least active. So here we have silver wanting to replace aluminum in aluminum chloride to produce a new compound. So using the activity series, we find silver, which is down here, and aluminum, which is up here. Since aluminum is more active, this reaction would not take place. Therefore, we could just write no reaction. Now we'll try again the same thing, but instead of silver, we're going to use calcium. So I look over to my activity series, and calcium is more active than aluminum, therefore this reaction will take place. The positive calcium, which is a +2, will switch places with the aluminum, which is a +3. And what happens is we now end up with calcium chloride, and I'm just balancing, so I need 2 chlorines to balance out the charge of 1 calcium, plus aluminum. Now we need to balance the equation. I have aluminum, chlorine, and calcium on my reactant side, aluminum, chlorine, and calcium on my product side. Now I will count how many total I have on each side and figure out where I need to balance. Alright, so it looks like chlorines are my unbalanced ion. So I have 2 chlorines on the product side, 3 chlorines on my reactant side. So I need to figure out what number 3 and 2 both go into, and that would be 6. So if I place a 3 here, that changes chlorine to, what, 2 times 3 is 6, and calcium to 3, which then changes, well, we need to put a 2 here, making it 2 aluminums, 6 chlorines. So aluminums are not equal, so I need to put 2 on my product side, and then to balance out calcium, I need to put a 3 on the reactant side. Now I am balanced. Now to look at another reaction, this is in your practice packet, page 4, letter E. It says the reaction of iron metal with oxygen to form iron 3 oxide. So we have iron metal, which is Fe, and that's a solid, plus oxygen. Oxygen is a diatomic, so we need O2 gas, and this is going to produce iron 3, so that's Fe with a charge of 3 plus, and oxide, which is O, which is a -2. This equation is not balanced, so I now need to place a 2 here and a 3 here. Now it is balanced. So now I need to balance the entire equation. So I have Fe on my reactant side and O on the reactant side. 1 iron, 2 oxygens. Here I've got Fe, I've got 2 of those. Oxygens, I've got 3. So I'm not balanced at all. So I need to figure out what am I going to do first. Let's do oxygen. I've got 3 on one side, 2 on the other. What goes into both of those would be 6. So I need to place a 2 here, which then gives me 4 irons and 6 oxygens. So now to get 6 oxygens on this side, I need to multiply by 3. 3 times 2 is 6. Now I need to balance my irons, so I need to place a 4 here to give me 4 irons. Then we double check to make sure that we are reduced as far as we can. 2, 3, and 4. They cannot be simplified any further, so we are done. And to test out what type of reaction this was, we had a synthesis reaction.